Hello. So this is going to be an example of rates of change, and again, rates of change is just going to be an applied differentiation problem, an applied gradient function problem. So let's go ahead and take a look at question number 1 here. A company mines copper where the mass of copper, X, is measured in thousands of tons. The company's profit, P, measured in millions of dollars, depends on that amount of copper that is mined. We have a profit function given by P of X equals 2.3x minus 0.05x squared minus 12. So, first thing that we have to do is find P of 0 and P of X and interpret these results. Well, I can first of all think about P of 0. This is a really simple thing. All we're doing is plugging in. And if I'm plugging in 0 into a function, that means I'm evaluating it when X is 0, or when the amount of copper mined is equal to 0. So plugging this in, I can see pretty clearly 2.3 times 0, 0 squared times negative 0.05. Those all go away, right? And then we're left with negative 12. So what happens when the company mines 0 tons of copper? Well, they lose negative 12. Negative 12, what? Millions of dollars. So here we can say company doesn't do so hot if it doesn't mine at all. So company loses $12 million. Now if we were to mine 6, and in this case again we are measuring this in thousands of tons, so this is going to be 6,000 tons, then hopefully the company is going to start making money. Let's see what happens. 2.3 times 6 minus 0.05 times 6 squared minus 12. This is something you need to punch into your calculator. You can go ahead and do that on your own. Pause it if you need to, just to kind of check. And our result here is going to actually be 0. No, you didn't do anything wrong. This is actually a very common value that we want to look at in business applied problems. We call this the break-even point. Break-even point is when the company is no longer, it's mining enough to not lose money, but it's not mining enough to make money. Okay, so company profit here is 0. So that's pretty simple. That's Algebra 1 applied stuff. We've done that before. Now we look at dp over dx. Well, again, this is just our gradient function. That means we want to do the derivation. We want to differentiate p of x with respect to x. So we do this derivation pretty quickly. 2.3x, we know that the x is going to go away. We're left at 2.3. Then negative 0.05x squared, that comes next. The exponent comes down, it multiplies with that constant to give us negative 0.1, and then x squared turns into x, and then the negative 12, that goes away. So this is our gradient function, and we know the gradient function is going to be a rate of change. However, what's it the rate of change of? It's the rate of change of the profit. So what that means for us is that it's the rate of change of the profit as the amount of copper mined increases. Okay, so now let's go ahead and find the value of the profit, P, when x equals 20 and x equals 25. So that's pretty simple. That's just like what we saw in part A. We want to say P of 20 is going to be 2.3 times 20 minus 0.05 times 20 squared minus 12. Again, you just need to punch this into the calculator, and this is going to give us the profit in millions of dollars when they mine 20,000 tons of copper, and that is 14. Let's see what happens if they mine some more. 25,000 tons, plugging in 25 into the function P, 2.3 times 25 minus 0.05 times 25 squared minus 12, and that is going to actually give us this time a little bit larger. So they are increasing their profits as they are mining more. So let's go ahead and see, well, what is that rate of change at those specific values? So what is dp dx for each one of those? Well, this is where we take that gradient function, the 2.3 minus 0.1x, but now I'm going to plug in the amount of copper that was mined, 20,000 tons. And when I punch this in, I end up with a value of 0.3. So what does that tell us? The rate of change is a positive 0.3. If our rate of change is positive, that means the function for profit is increasing. Okay, we'll touch more on exactly what that means in just a second after we evaluate what happens when we mine 25,000 tons. Well, here, 0.1 times 25 is going to give us 2.5, so 2.3 minus 2.5 gives us negative 0.2. And so notice how this is different. Now we have a negative rate of change. If our function has a negative rate of change, that means that the profit is decreasing. So that's where we have to interpret these answers here that we got in part C. Well, the first thing I can look at is what happened when we plugged in 20 and 25. We had a profit of 14 million and 14.25 million. So we can say the company is profitable, and considerably profitable when we mine this much. So we say the company is profitable when mining these amounts, 14 million and 14.25 million dollars respectively is their profit. And we can say also that when mining 20,000 tons, this is where we plugged in 20 into the dP over dx, we had an increasing rate of change. So when mining 20,000 tons, they can still mine more and increase their profits. And you'd think, well, yeah, if we're going to be continually mining more and more, we're generating more and more of this valuable material in copper, so why wouldn't our profit increase? Well, this is actually something that is very common in business, and this has a huge financial application, is that you're not just always going to be making more product and selling more product and then selling more product. Eventually you'll have a point where you've maximized your profit, and that's exactly where we see where the rate of change function really is important to us, because now what happened when we mined 25,000 tons? Our rate of change was actually 0. We had a decreasing profit function. So what that means is that when they're mining 25,000 tons, they are starting to see a decrease in profits if they mine more. So the question is now not just to look at where is that break-even point when we start from losing money to making money, but we want to know where is that maximum value. Now you could just plug in the function and find, okay, where's the maximum? But we can do this with calculus too, and this is why calculus is really important for us. This is where we first started to really understand how calculus can really be valuable. It's pretty simple to find where the gradient function dP over dx equals 0. Because what does that tell us? That's a turning point. We talked about this a couple of times. This function for profit, P, is a parabola. And we know it's opening upside down because I have a negative leading exponent. So that tells me I'm going to have a parabola that's opening down, and I'm going to have a maximum value. Well, that's a maximum profit. Well, what's the gradient function going to look like? What's the tangent line going to look like? The tangent line at that point is a horizontal line, and the gradient is 0. And this is exactly what we want to know. When is the gradient function going to equal 0? So what we need to do is we need to take that gradient function dP dx, which we know was 2.3 minus 0.1 times x, and we need to set it equal to 0. So now all we need to do here is solve for x, because we want to find that amount of tons where we are going to see a maximum amount of profits when we change from increasing profits to decreasing in profits. Okay, so now we will say 2.3 is going to equal 0.1x. I'm just moving that negative 0.1x to the other side of the equal sign. Now I'm going to divide both sides by the 0.1 to get rid of that. Then we have x alone. And here we'll see that x is equal to 23. So what does that tell us? Well, this tells us the maximum x coordinate is 23. Okay, but that doesn't tell us what the profit is at that point. That's what we want to find in part F. Determine p for this value of x, so that's going to be p of 23. And since I know I'm looking at p, that means I'm looking at the original function, which was 2.3 times x minus 0.5 times x squared minus 12. And what am I plugging in for my x value at this point? This value of x that we found that was going to be the maximum. So that's 23, and that's 23. Plug this into your calculator, and we'll see a value of 14.45. So that's the y value at this maximum point. Well, what's the y value in the max in this case? Again, what is it that we are looking at? We're looking at profit. That's the y coordinate. That's the y value. So this tells me this is the maximum profit that the company can make. And that's $14.45 million. So this was an Algebra 1 and Algebra 2 question that required us to, find the graph and to do that. But once we have an understanding of calculus, this actually becomes extremely quick. Now we asked a lot of questions here to kind of walk you through the process to understand how rate of change really applies. But once you really have a good grasp of calculus, you can find maximum just very, very simply by finding that gradient function and setting it equal to 0. There you found a maximum or a minimum value, and that's what we're going to learn in the next unit too, or next lesson. So go ahead and make sure that you've got your homework problems done and use this as a guide. Thanks for watching. Have a wonderful day.